Okay, so pandas is like working as a floss. Okay, you could even say is a free library open source software, mhm, which provides you the high level performance for data manipulation, analyzations, wranglings or cleanings around the data, doing some analysis all through over your data. Okay, so it comes in three of the very important modules to cover. That is the series, basically the three kind of data structures I'm talking about: the series, the data frames, and the panels. So we'll be discussing about the series and the data frames, okay, and some general functions of the pandas. So this is quite large library. We'll be taking up today and tomorrow also. Okay. So for the installation, if one is working with apart from this Anaconda or any in such like PyCharm or any other IDE, you'll have to install it by writing up there. That is, pip install this pandas. But if we have it, then in the Jupyter we don't really want to install it there manually. Okay, so we don't have to this, right? So for us, what is the one is that we'll have to import this pandas, and I always import it as PD. Okay, and let's quickly check what is the version we are using. So pandas version. So we are using pandas version as 1.0.1. Okay. Now data structures, when I say it, are of three kinds. That is series, data frames, and the panels. So these three are having their own dimensions. They have their own descriptions, and all right. So the structures are particularly of three kinds. That is series. Now, what is a series? Series. This is one dimension homogeneous labeled array, right? And what about this data frame? This is a two-dimension labeled array, okay, and mutable array, okay. Now, if I say that these are of three kinds, then obviously this data structures is going to be of three kinds. That is series, data frames, and panels, and each of them are having different dimensions. This is of one dimension, this is of two dimension, and this is of three dimension. Okay, so this is the keys, or you can say the data structures you're having. So data structures are of three kinds, and the values, that is 1 to 3, are their dimensions. You could get it properly. Okay, fine. Now when talking much about the series, we'll go in series with the details. So when talking about the series, so these are one-dimensional ND array with access labels, or you can say including the time series and all, right? So labels need not to be unique. It can be a hashable type, or it can be an integer, or a string you want to define. So operations, when we talk about the operations between the series, you can do addition, subtraction, multiplication, division based on indexes, and even the mean, sum, mathematical, some statistics operations, right? This can be done. Okay. So the parameters in a series kind of thing is always like you write data, you can write index, you can write data type, and even you can write name. That is the syntax. The syntax of writing a series is like PD. if you have only installed this pandas as import pandas, you have not written this as PD, you can just write it pandas dot the series. So I have like written PD, so I'm going to write PD dot series. And what I'm saying, you will first have to write your data. What is your data containing? Like what is the array? What or whatever you are taking as a data, like list, numpy array, or tuple, or any dictionary, or any scalar value. What you are taking. Then the index, and then the data type, and then you can write even the name of the series. So if you are defining your series name, you can even give that. So just taking up a common very basic series and giving you just an understanding of what exactly this is. So let's say this is 1, 2, 3, 4, 5, and the index to be as, okay, let's take it for 0, 1, 2, 3, 4, 5, and now not giving the index, and even now not giving anything. So what you can see, if I'm writing a series of something data which is equals to 0 to 5, okay, so what I am getting over there, that is 0 to 5 the numbers on the right hand side, and 0 to 5 the numbers on the left hand side. Now what is the difference between the 0 to 5 on the left hand and 0 to 5 on the right hand side? Why this is 2 times? So the difference is that in the right hand side what you are seeing from 0 to 5 is the data what you have printed, and the left hand side what you are seeing from 0 to 5 is the index number of the right hand side. Okay, so for the 0 the index number would be obviously 0, for the 1 it would be obviously 1, and so on for the 2, 3, 4 and 5. And the data type you could see there is an integer of 64 by default. So if we just make a series where we even write that my data is going to be 1, 2 and 3, and we write the name is going to be a unique. That's it. What I can see there, now a name comes as like unique 1, 2, 3, and right side your data is 1, 2, 3, left side the index values of those things. So 1 index value is 0, 2 index value is 1, and 3 is for 2. Okay, and the right side below you are getting up the data types, that is integer of a 64 bits. Alright, cool. Similarly, if we just we don't want the index every time to be coming from like this 0, if we don't want to start up our index with the 0, apart from this if we want anything else, our index will start up with something else. So in that case we can define our index even, right? We can write that pd dot series, and let's say this time your data is equals to 1, 2, 3, 4, 5, and let's say this time we are giving name as defined index. And let's say that we are even taking the index as A, B, C, D, E, and what left, let's say data type we are defining as, okay, let it be, because we haven't imported numpy, so let it be only with a 3. So what you can see that there are some numbers 1 to 5 with the index numbers from A to E, and the name over there as the defined index, and the data type will be there. Okay, now to change the data type you'll have to import the numpy, and then you can go with that. So let's say this is import as np, and now we can write as the d type is going to be np dot whatever you want, float of 32, write it there, and we'll be getting up the things accordingly. Okay, Now in the series, once you have defined up the things, or even if you are getting up a series with some data frames, we'll go it on later onwards. But I'm saying you right now, okay, that if you have defined a series and you want to check whether a series index is what, right? So you want to check what is the index of a series. So to check the index of a series, what you can write, so I'm writing it there. So the syntax is pandas dot the series name, and then you go for the index. Okay, then you go for the index, or here you can just write the first write the series name, and then you write the index. That's dot index, and this gives you the index of the series. Okay, this gives you the index of the series. So that is, if I just write this, gives, sorry, this gives you, and this function works as well in the data frames too. Okay, so well, my series name is nothing because I haven't defined any series. I have just printed them up, right? We haven't stored any series. So let's say this is my first series I'm going to define now, and this is series, and my data I'm going to take np dot some random data of 10, and let's say 5, and same we are going to write the index to be 5. Okay, and let's just run this. So, and if you want even to give the names, we'll be giving it so that we can just identify what is being there with even the name only. So let's say this is going to be random series. Done. So if I check my x, it would be a series, and like these are my values and these are the index numbers. Okay, so that is index number. So x of 0, key error. We got some key errors, right? So why? Because index numbers are quite different. So what is the index of this series x? So print the series of x. So these are the index, that is float 64 index, and these are all the index I'm having. Now like this you can define up your index. Okay, now let's say if this is the y and you're making something else series, so let's just say this is series, and now taking small data and the index to be a b c, split name to be list series. Okay, so name I'm going to give as list series, right? Okay, so if I see my y, it is going to be a b c as 1 2 and 3, and then the name is going to be list series and the data type is going to be integer of 64, right? I think that is clear. Okay, fine. Now, so similarly, if we are going with the other patterns of like finding up the values, so if I write x dot values, so then it would be 0 point something, and okay, we have to find the values for y. So y dot values gives you an array, if you could see. So that is what we are defining, that a series is a one dimension array. Okay, a series is a one dimension array, and you are getting the array as to be one dimension if you have seen in the numpy that these are the one dimension ones, and you get it like this. Okay, now moving up to the next one, right? So this is very clear, right? If you see up the series of any index and all, right? Okay, 1 minute. Now, as I said that there is a one dimension array, then what is an array? If I'm saying that y dot array, and what you can see that this is a pandas array of length 3 and the data type as integer 64, right? So series is very clear to you, I hope, right? And then so what the next function we used is the values. Okay, and in the next one what we used, because functions are very important, how many functions you learn, that is important. All right, okay, getting next. So apart from all these, there are, as I said, that here we haven't defined any data type, but we are getting the data type as always by default. Here is an integer of 64. So if I say that you're going to see about the data type, so if you have a series and you just check it for the x y dot d type, you'll be getting it like this. If even you write like the name or just the d type, let's see, so this is an integer of 64, right? That is very similar to the numpy of 1 what you made there. Next we have for checking a dimension of a series, the series dot ndim for checking the dimensions, if you remember up the with the numpy. So that is y dot ndim, that is one dimension. Always you'll be getting one dimension for the in the case of a series. Okay, now if you remember up the size or the length what we used to find up in the numpy, that was any array dot size. So this is also a one dimension array, so we'll be writing it as what is that, size. Okay, so how many elements are there? There are 3 elements, and you'll be getting accordingly. Okay, now if we checked something using the sys module, right, the size and the memory usage of the program and the get size of 1 what we used. So here if we want to see up sorry, this is series. If you want to see up the size of my whole, you can say the size of the whole array, or like the components inside that, if you want to see, if you want to just find out the memory usage of that particular series, we can use memory usage. Okay, So this would find you the, or you can say this would return you the memory usage of the series. Okay, we write y dot memory usage. So it's using 128 bytes, including your index. Okay, so if inside here you write index equals false, you'll see the difference there inside your usage, right? Why? Because index is also having some spaces. Okay, index is also storing some spaces, because see, if you see your y, this is 1, 2 and 3. So you are getting a complete memory usage of 1, 2, 3 plus your a, b and c. So if you remove up your index, only you will be seeing the memory usage of this 1, 2 and 3. Okay, like what individual this is storing up. If you only write the memory usage, you'll be getting everything up there. This is how it works. Okay, next we'll see up the S type. Now what S type means, that when I want to convert something, if you remember with the pandas, because I am just trying to make you remember all the functions we did in the numpy, right? Because there was a gap between the numpy and the pandas of the scipy, so it's with the simpy, right? So if you remember that in the pandas, in the numpy we did something called as S type. It is a right S type of any you can say data type, so it will change the data type of that respectively. So if I write this as S type to like boolean, so you can see the results as true, 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 or anything, right? So only in the case when it is 0 or like it is as false return, then only you are getting a false results in the booleans. Otherwise you'll be always getting it as a true result, right? Okay, now, if you want to copy up a series, you can just write series.copy and series.boolean, and you can even get the respective things as you want. Okay. All right. But what if I write as a pandas dot series dot numpy? So if I write this function, what happens? The series will be converted, or you can say the series will be get converted to numpy. So I will have to write it as 2 and then underscore to this numpy. Okay, 1 minute. What is this going on? Okay, fine. Let us focus here. Okay, so this is pandas.series to numpy. Okay, now let's say this is y and we are writing 2 underscore of numpy. So if we run this, we'll find an array, and this is now like changed to a array. Similarly, we are having if we want something to the list, you can write pandas dot series. Now you would be wondering where to apply all these series and all, right? We'll go in that also, right? So if we want something in the list, we can use this and we can get in the list. Okay, right? So in a series, we can even perform multiplication, division, this addition, subtractions, and all with a very basic function. And what is that? Like, if now we say that this is my u, which is going to be a pd dot series of 1, 2, 3, 6, and the v is going to be pd dot series of okay, so these are u and v. And now let's say that we want to operate or we want to use some common operations here. So what should we use? How should we use? Okay. So PD dot, let me write it there. What we are going to use is pandas dot series dot. We are going to use add. Okay. We are just going to use the subtraction. That is sub. We are going to use multiplication. We are going to use division. Okay. You can even use the powers and all. You can use the powers. You can use the float division. You can use the modulus. All right. You can use various things accordingly. All right. So now u, when we want to add up. So u dot add with v. So we'll be getting the corresponding results 10, 10, 10, 10, 11, and 11. That is exactly correct. If you see up the things, it is 9 plus 1, 10, and 8 plus 2, 10, and then 7 plus 3, 10, 6 plus 4, 10, 6 plus 5, 11, and 6 plus 5, 11. Okay. Similarly, you want to like subtract something from the u. So you can write u dot subtract this by v, and same for the multiplications and divisions. Now, where this series will be used in the real life data, you might be thinking with that, right? So I'll be giving you one example. When we'll go in the data frames, where they will be dealing with the columns and the rows, they will be requiring up this all series and all. So it is very important to understand the series functions, how this works. Then we can just manipulate over that, all of that, say for data frames. Hmm? Okay. And what is like power? What is if we just want to define any like power or exponentials? You can say. Hmm? Exponentiation values. So if you remember, I said that in the numpy, if I write something as np dot n, that means a nan. It's not a number. Hmm? If I write a is equals to pd dot series 111, and let's say np dot nan, and let's say our index is equals to a b c d dot split. Okay, so the list of this is this, and that is our a. Similarly, let's just make b also. So this is going to be the series, and let's say 1 nan 1 and nan. Okay, so 1 nan and 1 nan. Now here too we'll write up the index. So this is my a and b defined in. Okay, now okay, some so what is a? If we just check it, this is 1 1 1, and the nan value what we given, that is d is occupying nothing, right? So if you write up for that a of d, it will be getting nan, that is not a number. Now what is for b? So we are getting 1 nan and 1.0 nan, so 2 nan in the b and 1 nan in the a. So you could see other things. Okay, now I think here we added 1 2 3. Okay, fine. Now, so to apply up the power, we can just write that A in the power of B, and the things are there, right? 1 1 1 nan. So that is exactly. Now let's just change up some data. 1 2 1. Let it be 4, or let's change even this 3 1 3, and run this. Okay. So A value will be changed up. This is 3 1 1 nan, and B is 4 nan 3 nan. But A to the power of B will be giving like this results 81 1 1 nan. Okay, right? Okay, so this is like how you write up for the powers for finding out the things here. If you write np dot, like you want to find the mean values of a particular series, so np dot mean of define of the series, that's all, right? A, and like the things, and even like if you want to find up the modes, or you want to find the whole sum of this A, be giving you, right? So nan values are there, right, guys? So could be a bit difficult to find up the sum, so it is nan. And if you say like A of 0 and B of 0, you can write A of A plus B of 0. So there's the results. So A plus B of 0, what is A? That is 3 1 1. And what is B of 0? That is 4. So 4 plus 3 7, 4 plus 1 5, and 4 plus 1 5, and nan 4 plus 9 is nan. Got it? Getting next. So these are the common operations we do up in the series, and I hope that is clear. Okay. Now similarly, we like will go up with all of the different functions used up in the series even more, and we'll quickly now jump up into the data frames to work with that data frames. Okay, so series operations are clear to everyone. Write a quick confirmation here, yes or no. Any doubts in any of the operation, you can ask me. Is series clear to you all? Yeah, practice is needed, that's okay. Okay, what about Abhijit and Almas? You guys have got understood how series work? I hope that is clear to you all. Okay, all right. So we can make a data frame using a dictionary event, and we'll go in that part later onwards. First, we'll try to understand what is data frame and what are the various different type of the functions used to define it, or what are the different things used to operate inside a pandas. Inside a pandas, what are the things used to be there? Now there are various functions like date range and all. We'll be discussing it. We'll be going up with the date range and all, right? So first of all, let's just discuss all the functions and then we'll go to data frames. I'm thinking that if I start data frame from tomorrow, that would be much better. So if we're going to start up with the data frames tomorrow, then let's just complete up with the functions and all, right? Before going to data frames, what are the important functions? There is something called as date range. So what is this? This returns your fixed frequency of a date time index. You You might have heard about this, right? Date, time, and all. That is whenever you can say even a timestamp. So whenever you just enter any form on an online web application, so what happens? Your form is being submitted with the date what you have entered, even with the time you have, like when you have submitted. Okay. So in a date time, you have parameters like you have starting date or the time, like whatever you want, the ending one, the periods that would be defining like of how many dates you want from the start to end. Or you define the frequencies that can have multiple strings like hours or minutes or anything. Okay, we'll go in that too. So very famous four parameters are start, end, periods, and the frequency. Okay, so we'll be giving examples to just define you how to get up the things. So let's say we specify a start and an end, and how it works. Like if we want to get a date, a range of some dates, and we say that what is the start date? Let's say it was 21, 8, and 20. And what is the end date? 38, 20. We have to write it complete. Okay, and just run this. So what do you see? 1, 2, 3, 4, 5, 6, 7, 8, and 9, 10. By default, you have got some 10 dates, and not you can say by this by default. Even you have given the end and the start, so you are getting it accordingly. Okay. So starting from 21st August and ending at 30th August. So here no periods is required. Periods are the number of the days or the number of samples we say in the form of mathematics. So here no periods is required, right? We just define up the starting and the end. So no intervals, no periods here. So if we define the number of periods or the number of days, then we'll not have to define like the end one. So there you can write pd dot date range. You say only your starting date 21/8/2020, and you want some 10 dates. That's it. It will go till whatever you have defined it. Okay. So if you define that what is your end date, and from there if you define your periods, then again it will be going accordingly. Okay. So if you defined your starting date, your ending date, and even the periods, okay. So if you define it, all the three things, what happened? Let's see. So let's say starting date is 21st 8 20, and it's going till 38 20, and periods to be 10. So what you got? The frequency to be none. You can see the difference. Frequency is going to be none in this case, right? Because this frequency here is generated automatically, right? Okay, this is automatically generated of the things over there. Date time index. Now if you want to change the frequency to month, okay, if we want to change this frequency to month, we can define that frequency is going to be like month. Okay, and what could be the difference, right, in that case? Let's say this is my start strt, and let's say this is 21 8 sorry 8 and then 2020, and let's say this periods is going to be like for the 10, and we have defined our frequency as m. Okay, so what you could you see the difference up here? That is, I could see the difference: 31/8 2020, 39 2020, 31/10 2020, 30/11 2020. So what is the difference, right? So you are getting 10 periods, or you can say even the 10 months, you could say, right? It is going 8, 9, 10, 11, 12, 1, 2, 3, 4, 5. So accordingly to the month, you are getting the ranges. Now, if you focus that this is 2028, 31st August, then 39, 2020. So now you are not getting the frequency as per the days. This is not according as per the days now. This is according to the days. Now this is according to the month. Okay, and even it can go according to the year, right? So like for one, second year, third year, fourth year, fifth year, sixth year, and so does the seventh year. Okay, so even you can apply it as 3m, right? That is multiples you are giving up there. So what is the difference if you write up as 3m? So 31st August 2020, then you are getting 30, 11, then like the intervals what we are talking about, right? So the intervals we are getting up there, okay, and in the like occurrence of the things. So like in the 3 months occurrence. So 31/8/20, 31/8/21, and 31/8/22. 30/11/20, 30/11/21, 30/11/22, 28/2/21, 28/2/22, and 31/5/21, 31/5/21. So you increase the periods, you'll see other things. Okay. Now you can even define up a time zone of wherever you want. Okay. Like if you write up that pd dot date range, and let's say your start date is going to be 28, so 21, say 8. Okay. And similarly, let's say for some 5 days. And what is TZB? So if you say according to this India, according to this India, why? Function is not working. Okay. Time zone, time delta, time zones. Asia Tokyo is working. Date range. Conversions. Hmm. What is the localized index of this? Okay. Fine. Okay. So like if we want to convert this in this, like if it is a series and we want to convert it in a time zone, I'm seeing it there like if we are having a series and we want to convert this in some time zones, we could write it as dot and then ranges. Like if this is a date range and we want this to be converted in some, let's say this is di equals to this. So this is my di, right? And uh, if we want this time to be converted in something else, like let's say for the Berlin or let's say for the Central, so di dot time zone conversions. So time zone convert and but why this is not working? I have to look over it. It's not taking up. Okay. So let's say for the Berlin, it is also not. Right, Berlin is in Europe. So, 1 second. Why? So if we just see up the time zones, where is this Asia? Is there for Kolkata or something? Yep, we have for Kolkata. Okay, I was making it for the country, that is for the city we are having. Okay, so changes accordingly. Like for our time zone is always like the 5:30 plus GMT plus 5:30. If you see up the things, 1 minute. Okay, so like this is the library of PYTZ, that is Python time zones. And if you write up like to get all the time zones, so how many time zones are there? If you could see up that, if you write up the length of this, so 592 time zones are there. Apart like from there, you can get it accordingly. So if you see up for the country time zones, these are useful when you are creating data frames for uh, like let's say for any particular country, right? Let's say we are looking for India. Again, let's say for looking for US. All right, we got it. So for US, we are having so much things. What is the problem here? Asia, Australia, and like if we write up for the Asia, so these are all about the Asia, right here. Still there is some issue. ASIA not working. I have to see. Okay, so there are factors, and why I'm using this timestamp, I'll let you know, right? So if you remember, like on some day we made some Google codes, right? So if you remember of the things like what exactly is a data frame, how to deal up with the data frames, right? I'll make you see that how this thing works. Just giving you a small description of that. So let's say this is my H and this is a blank list. Okay, what we can do with the data frames, how we are going to manipulate of the things with tomorrow, like with the data. So H is going to be a list, and let's say for I n np dot range of let's say 10,000. Okay, we are going to generate, okay, let's just take, we are going to generate some uh, three, yeah, so we are going to generate some 1 lakh codes. Okay, so just 1 lakh codes we are going to generate up now. So g is equals to np dot random dot random of some starting from 1 2 3 4 5 6 and going till 7 8 9 0 0 4. Okay, so this is my range, and what I'm going to do is h dot append this g, and then I'll be making it as an array. Sorry, this h is going to be an h, the easy one. Conversions, just wait some moment. Yeah, so almost 2 to 3 seconds has been taken up there. Okay, now I'll just show you that how we can make up the things. Like if you just see up to the h, what is h? H are a codes. H are just the codes given there, right? If you write it as g or something like there, then it would be obviously going to be a Google code. So these are the codes particularly for now. Just see of it. Okay, so if you remember, like we use some unique functions and all to find out the unique on the h. So what is the length of this unique of this h? 92814. And what is the length of this h? So h is 1 lakh, and we are having 92,814 non-identical, uh, you can say inidentical numbers. Okay, so apart from this, we are at minus 92814. So there are 7,186 identical codes, or you can say these has been these have been just uh, duplicated, or maybe more than for 2 times or 3 times would be have replaced. So if I say my df and just making it as like giving an example, we'll start up with this data frames. So let's say I'm giving my df as this, and what I'm going to do is one more thing I'll be doing it. The h will be resizing this h, or let's say reshaping this h to let's say from so this is 1 lakh, so let it be uh, yeah 1 lakh. Okay, and this is going to be my data frame, or you can say my data sheet, what I'll be working on. And now here I'll be making my index at pd dot the state range, and here I'll be saying that I'll be starting it with the not index, I'll be going up with the columns. So columns, I'm making it start range to be from 21 8 and this 30, and I'm going to find the first 10 days as my columns. Okay, and that's it all. So df is not defined, or sorry, this is equals to h. So this is my df, and if I just show you my df, so you could see up some codes over there, and on some particular dates, right? So 21, 22, 23 until 30 it's been given. So if I just see up the head of my data, so I can see that there are the codes individually, like on 21st, how many codes we have generated? We have generated all these codes. So what are the codes we generated on this particular day? Now when we go on searching for this, when we'll start up doing with this reference, like when we'll be starting up with going with the columns, then we'll see that we require this, right? What we require? Then we'll see that we are going to require this particular series. Now if you can see that there is a name of this particular time, and that is a series, and then the length is given, the type is given, and then you have only to manipulate on the series. So that was a series of 5 to 10 numbers, and this is the series of some 1000 numbers, right? So 1000 numbers in a row and 10 columns. Okay, no, sorry, 10,000 numbers in a row and some 10 columns accordingly, right? So you're going to manipulate on these all. Okay, so we will be discussing about these things in a brief. We will see that df2 underscore of html, and making it as just random dot html, and just making it there. So if you could see over the drive, here's some random.html. If I open this, this is around for 2.59 MB, and if I see, you could see of the date ranges, or you can see the even the dates. And what are these things? These are the codes what you generated, and you wrote in some Python code, and what you written, just a couple of, not a couple, just you wrote some 5 lines, take it more as like uh, 6 and 7, so 7 lines and one more, that is 8 lines. So if you know about something about the HTML, you would know that if you want to create a table in an HTML, you would get almost around 15 to 20 line of codes, writing a td, th, and all those stuffs for making a table. But with some 8 to 10 lines, we have generated an HTML table, you can say, and that is almost having some 10,000 rows and some 10 columns, or you can say we have generated within 3 seconds or 5 seconds one complete table of 1 lakh data, right? So these are some random datas, or we'll be working with some real-time datas, right? That is like for when we will go in the modelings, and we'll be working with some of the real times. These are just for you, just to show you that in the coming days, like will be when we'll be dealing with the datas, we'll be needing these series. So this is as important, right? Because whenever we start up series, like students have doubt where we are going to use the series. These are not going to come in any kind of thing. So these are very important, because when you deal up with the data sets, you'll be going up with the series. And the state range is also important, right? If you have nothing, like if you don't give anything inside in the columns, you will get the columns as a b c d, or like 1 2 3 4 and like this. Okay, accordingly to that you'll be getting up the things. Okay, that is how it works. So I believe that